Welcome back to Let's Learn Calculus. Today we're going to look at limits, the definition, and some examples. Recall from our last video, we want to find the speed of a car traveling along the path p of t is 2t squared plus 3, when t was equal to 5. We discussed that we were able to find the average rate of change between t equals 5 and t equals 10, but we weren't able to find the speed when t was equal to 5. That is, we weren't able to find the instantaneous rate of change. So since we couldn't use our average speed formula, we had to use the idea of a limit. That is, we had to find the number L so that whenever t was close to 5, the average speed was close to L. So recall the definition of a limit. The limit as x goes to x naught of f of x is the value L, so that for all epsilon greater than 0, there exists a delta, so that whenever 0 is less than the absolute value of x minus x naught is less than delta, we have the absolute value of f of x minus L is less than epsilon. That is, whenever x is close to x naught, f of x is close to L. And we denote this as the limit as x goes to x naught of f of x is equal to L. Example 1 asks us to use the definition of a limit to prove that the limit as x goes to 5 of 2x minus 1 is equal to 9. What this is actually trying to ask us to show graphically is that if we have the line 2x minus 1, as x gets close to 5, what we have is 2x minus 1 is getting close to 9. So this right here is the point 5, 9. And as x approaches 5, our y values approach 9. Now how we're going to do this is we need to start off with some scratch work. So the first thing that we need to find is we know that we eventually want the absolute value of f of x minus L to be less than epsilon. So what that means is that we want the absolute value of 2x minus 1 minus 9 to be less than epsilon. Well, let's just work with this 2x minus 1 minus 9. So if we start off with 2x minus 1 minus 9, this is equal to the absolute value of 2x minus 10, which is equal to the absolute value of 2 times x minus 5. And because of how absolute values work, we're able to factor out a 2. So we have 2 times the absolute value of x minus 5. Now remember, we want this to be less than epsilon. But what we also want is we want x minus 5 in absolute values to be less than delta. So we have the absolute value of x minus 5 is less than epsilon over 2. But we also want this to be less than delta, so let's set epsilon over 2 equal to delta. Now when we go to write up our actual proof, so we'll let epsilon greater than 0 be given, and we will consider delta equal to epsilon over 2. Now what we have is the absolute value of f of x minus 9 is equal to the absolute value of 2x minus 1 minus 9 is equal to the absolute value of 2x minus 10 is equal to 2 times the absolute value of x minus 5. We know we wanted x minus 5 to be less than delta, so this is less than 2 times delta, but we said delta was equal to epsilon over 2, so this is 2 times epsilon over 2, which is epsilon. Thus, whenever x minus 5 was less than delta, f of x minus 9 was less than epsilon. Therefore, we have the limit as x goes to 5 of 2x minus 1 is equal to 9. And that's going to do it for this video. Hope you guys liked it. If you like it, hit the like button. If you have any questions, feel free to leave them in the comments. And be sure to follow me on Instagram and Twitter. Both their links are in the description. And I'll see you guys in the next one.